Okay, good morning to all of you. Now please let me know whether this slide is visible and am I audible? Anyone, please respond.
Yes,
Yes, sir. Yes.
Okay, so I welcome to this new course on introduction, the software testing. So we say very good morning, and let's see how we'll plan to go ahead. So first of all, I'm sorry joining late because there was some internet problem. So get late in joining. Today we'll finish up in right time, and we'll take only the introduction, basic concepts of testing. Then we'll discuss the other things gradually. Okay. Let's see. Testing is coming under what kind of technologies you can say. You know there are different defect reduction techniques are there. How to remove the defects from softwares. So many methods are there like review where you have seen code review and this what you can say design review etc. Review is a very good mechanism for removing defects. Testing is another important technique for reducing the defects. Similarly, other techniques they are used for defect reduction are formal verification, using a proper development process, using proper systematic methodologies. These are different ways to reduce defects in a software. I'll say one of the importance of testing. Why testing is so much important? Let's take a small example. You might have known before a few years there was a rocket called as Ariane 5. And when this Ariane 5 software, this rocket was developed and it was launched, it was just self-destructed after 37 seconds of its launching. Why it was failed? Why it was fall down on the sea? You please see, the rocket is here and it is just launched. After a few seconds, you say it is smashed and is falling into the sea. So why that has happened? Why it was self-destructed? Let's see the reason. Many of you might have already heard this reason. The reason is that a control software bug that went undetected. There's a small control software bug which the engineers could not have noticed. What is that bug? You know that while you are converting from integer to float or float to integer or the signed to unsigned, etc., there is a specific range. While any conversion will take place, there is a range like minus this to plus this. There is a range. You might have known this thing. So similarly, there was also a conversion process. This conversion from 64-bit floating point to 16-bit signed integer value had caused an exception. So while this conversion was there from 64-bit floating point number to 16-bit signed integer, it has caused an exception. Okay, so when there was a conversion in this software which was developed for this Ariane 5 rocket, so in that conversion from 64-bit floating point to 16-bit signed integer value had caused an exception because the floating point number was larger than the prescribed range. And what are the prescribed range? It is 32,767. So this floating point number was larger than the value 32,767. That's why this conversion has led to an exception. The efficiency considerations had led to the disabling of the exception handler. You might have used Java and you are using this try catch plus etc. to handle the exceptions. So while the engineers have developed this, so they could not have looked at this particular specific range for this conversion, and as a result, this conversion has led to an exception. The efficiency considerations had led to the disabling of the exception handler. That exception handler was disabled. So that's why, due to this minor problem, see the Ariane rocket, it was just smashed in the air and fallen into the sea. And you know how much money they have spent? So they have spent almost $1 billion for developing this rocket, and you see it was just smashed within 37 seconds after launch. Very minor bug due to lack of oversight. So had it been the case, they have properly tested this software for this Ariane 5 rocket, maybe this error could have been detected, a very minor error. And due to this minor error, see what is the consequence. So this is the importance of software testing. Why do we require to test the softwares as thorough as possible? Then let's see, how do you test a program? Like this. You in the first stage is you have to supply input test data to the program. Okay, give input test data to your code or to your program. Then you observe the output. If the expected output is matching to the actual output, okay, then no problem. If they are not matching, then some problem is there. Note down the conditions under which conditions the expected output is not matching with the actual output. Note down the conditions and then try to detect those errors. So observe the output, check if the program is behaving as you are expecting. If not, what you will do? If the program does not behave as it is expected, note down the conditions under which the software failed. Then later on you can debug and correct. This is how how do you test a program? Okay, so in this way you test a program. Very in a layman's point of view, I have told how to test a program. We'll see the systematic methodologies later on. Now let's see why it is so hard about testing. It should be very easy. What makes it difficult? I have taken a simple example.
Sir, which slide is this? PPT is this?
Sorry?
Which PPT is this, sir?
Which PPT this means?
This PPT which you are showing, which PPT, where can I find it, sir? Is it in the team?
No, I have not uploaded this PPT. After this class is over, then only I will upload. You are able to see the PPT or not?
Yes, sir. I'm able to. I was making notes, sir. So I was getting late, sir.
No.
Changing slides.
Please make a point that after teaching one class lecture, then only I will upload this slide in this. What's your name?
Okay. Chandrakant, sir. Chandrakant. Chandrakant, sir.
So you have not attended software project management last time?
Yes, sir. I attended, sir.
But many classes absent in software project management. Many classes you are absent. And this practice you did not notice in last time. That as soon as the class is over, then only I will upload.
There were some PPT uploaded out. I thought it is one of them, sir.
No. This is last year's thing. So because I have not created every year, I cannot create a new team. Last year software testing team was there. I have removed these old students. I have added the new students. These documents are there. So you have to first concentrate on the lecture what I am giving. Then only later on you will see where it is there, which the file. That means you are not listening carefully. Only where the file is there you will see and just have to copy paste or those kind of things. Please try to understand and then you can refer. If it is not there, then I will upload it. Okay. So
excuse me, sir.
Yes.
Sir, my friend pinged me and told he is not added in the team. Akshay Saraugi, sir.
You tell it he can write a mail and talk to me. Those kind of things don't disturb in the middle of a class. Anything else related to the class you are not understanding, you can interrupt me. Anything else which is not to this lecture kind of thing, please keep it after the class you tell. Those kind of things please do not disturb in between. Okay. And it is his lookout. He should my telephone number is there with almost all. My mobile my email is there with all of us, all of you. So they can contact me. Okay. So this is the way how you can test a program. Why it is so hard about testing? So let's take a small procedure like procedure 1, and it takes two variables integer x and y. Let us assume that we are having a 64-bit computer. So what will the input space now? The input domain or the input space will be 2 to the power 128, isn't it? And now let us assume that it takes only 10 seconds to key in an integer pair. To enter an integer pair xy, it takes 10 seconds. Then how much time it will take? It will almost take a billion years to enter all the possible values. Very, very primitive, which is not possible. And if you will automate this process, automatic testing has also its own problems. So these are some of the facts why testing is so much hard. Cannot give guarantee that how much thoroughly you have tested a program, it is error free. This much guarantee you cannot give. Now let's quickly look at some of the important facts about testing. Testing this phase, you know that software development life cycle, where the different phases are requirement analysis, design, coding and unit testing, integration and system testing, and then implementation, maintenance, etc. If you take all these phases, you can divide all the phases into two groups. One is development phases, another is maintenance phase. And you know, maintenance takes almost 60% of the effort, whereas development takes 40%. And if you will take among all these development phases, what are the development phases? Requirement analysis, design, coding and unit testing, then integration and system testing. So this testing takes again 40% of this development effort. That means 40% of 40%, almost 16%. So it may vary from 40% to 50%. So this phase consumes largest effort among all the development phases. So largest manpower is required among all other development roles for the testing purpose. This implies that more job opportunities are there in this testing phase. But people, I do not know why people are scared of, they are afraid of joining this testing phase. Huge job opportunities are there in this testing group. About 50% or somewhere it is in 40%, it will vary little bit. So it about 40% to 50% development effort is it takes about 40 to 50% of the development effort. Which one? Testing phase. So testing phase almost takes about 40 to 50% of the development effort, but 10% of development time. But if you see that actually for development time, you just take for 10% of the development time. Okay, let's find out how. Testing is getting nowadays more complex and sophisticated every year. Why? We'll see some of the reasons. One, due to larger and more complex programs. Previously, you see only these small programs are there. The programs are consisting of some hundreds of lines. But nowadays, see the problems that the programs are becoming more and more complex. Previously, this railway reservation system was not there. You are going and standing in the queue to book to reserve a ticket. This banking information system was not there. So where now this, if you imagine this railway reservation system or banking system, they consist of lakhs of lines of code. They are becoming much larger and more complex. So obviously testing a larger and complex program, it will be much more difficult than testing a smaller program. The newer programming paradigms, previously only this basic Fortran, Pascal, COBOL were there, but nowadays new programming paradigms such as object-oriented paradigms, aspect-oriented programming, agent-oriented programming, new types of programming paradigms are coming, and these programming paradigms, they pose special difficulties in testing the software. Let's quickly look at overview of the testing activities. So first step in testing, you have to design the proper test suite. What is a test suite? Test suite is a collection of the test cases. And what is a test case? I will just define now. Then we have to run the test cases. So after designing the test cases, we have to run the test cases and observe the results to detect the failures. Then we have to debug the software to locate the errors at the different positions. So debug to locate the errors, and then we have to correct the errors. After locating the errors, we have to correct the errors. These are the what we can see overall activities for this testing phase. Now let's quickly look at about what is the difference between error, false, and failures. So for a layman, maybe same the terms error, false, and failures, but actually they are not the same. A failure is a manifestation of an error, also defect or bug. Okay, failure means it is a manifestation. Manifestation of what? Manifestation of an error. The error is also known as defect. It is also known as bug. But please remember that just mere presence of an error may or may not lead to a failure. An error is there means you cannot that the software will fail. So just mere presence of an error may not lead to a failure. But whenever you say that a failure is there, obviously some error or some faults are occurred. Okay, whenever a failure is there, obviously some errors or faults have occurred, but just the mere presence of an error, it may or may not lead to a failure. Well, I'll give a very interesting example of testing here. You know that these farmers, while they are going to their fields, they are applying different pesticides. Why? To kill the insects or the germs. Now, please imagine suppose they have taken DDT or something else, some pesticide, and sprayed in the what field. So definitely some of the insects will be killed, but still some of the insects, they will not be killed. They will just able to manage, because now they are more powerful than these what pesticides. So some of the insects, they will try to manage. They will survive. They will creep into what the next phase. They will survive. So now the same amount, the same dose of DDT or the same pesticide, how many times you will what spray you apply, those left out insects will not be killed. You have to change the pesticide. You have to add, you have to spray different pesticide, more powerful pesticide. Then only those left out what insects will be killed. Same thing happens here. If you have employed any particular testing technique, detected 8 bugs out of these 10 bugs, another 2 are left. The same technique, how many times you will apply, they cannot be detected. So what you have to do, you have to change your testing strategy. You have to use a new powerful testing strategy to detect those two. The same amount, the same technique if you use, those remaining or left out bugs cannot be detected. This effect is known as pesticide effect. It is having strong resemblance with this pesticides that the farmers are spraying in their fields. That's what I have told here. The errors that once escape, okay, the errors that escape a fault detection technique, they cannot be detected by further applications of that technique. How many times you apply the same technique, the remaining errors, the left out errors, they cannot be detected. You have to change the testing technique. Okay, this is known as the pesticide effect. Now let's take a quick mathematical example. Let us assume that we use 4 fault detection techniques, and let us assume that there are 1000 bugs in that software. Since you are using 4 fault detection technique, let's say that each fault detection technique, it detects only 70% of bugs. Now the question is, how many bugs would still remain? So how many techniques you are using? 4 techniques. Each detects how many bugs? 70%. That means how many left? 30% bugs are still there. So 1000 into 30% means 0.3 to the power 4, which is equal to maybe approximately equal to 81 bugs. That means even if you have used 4 fault detection techniques, still 81 bugs will remain undetected out of this 1000 bugs. In order to detect those 81 bugs, you have to use some powerful other fault detection techniques so that these remaining 81 bugs can be detected. Okay. This is something known as pesticide effect, very, very important, very much important. Now let's quickly look at a fault model, because in testing means we have to detect the faults. So let's see the fault models. What do you mean by fault model? Fault model contains the types of faults possible in a program. So in a program, what could be the possible types of faults? Fault model represents those things. Some types can be ruled out. Okay, some of the possible faults you can rule out, like concurrency related problems in a sequential problem. You are using you are writing a sequential program. So concurrency related problems you might have seen, like dining philosophers problem, reader writes problem, etc., where concurrency is there. But if you are designing a sequential program, obviously the concurrency related problems, they will be ruled out. Okay, so like this. So basically fault model means it will contain the types of the faults possible in a program. So here I have summarized the possible faults. I have taken only here, of course, object-oriented program. If you check, because nowadays many people are using object-oriented programs such as C++, Java, etc. So the fault model of an object-oriented program looks like as follows. All the object-oriented faults can be divided into 2 major categories. the structural faults and the algorithmic faults. Again, structural faults can be divided into many categories such as procedural faults, traceability faults, object-oriented faults. That I mean, due to the properties of object, these object-oriented faults means due to the properties of object-oriented programming, like faults due to inheritance, faults due to polymorphism, faults due to dynamic binding, like this. And algorithm faults means you have to see they can be divided into two major categories: the incorrect results and the inadequate performance. If the result is incorrect, obviously that is due to the algorithm, faulty algorithm. And if you are getting correct result but the performance is not adequate, performance is not sufficient, it's very poor performance, then also this is due to some faults in the algorithm. So these are some of the faults only I have listed. You can find out other faults from books or from any internet resources. So here I have given you a simple hardware fault model where it's very much easy to detect the what faults in a hardware. So let's discuss about this hardware fault model. This hardware fault model is very simple. Maybe examples you can say stock card 0 or stock card 1. Maybe this faults due to open circuit or short circuit. So there are simple ways to test the presence of each. So I have given some simple faults here. So in order to detect those faults, many simple methods are there. There are simple ways to test the presence of each types of these faults. So hardware testing is normally it is a fault-based testing. You are trying to detect the faults. So hardware testing is one kind of fault-based testing. Okay, hardware testing is a type of fault-based testing. Now let's go for software testing. So each test case typically tries to establish the correct working of some functionality. In software testing, what we are doing, we are trying to design some test case. What is a test case? I will tell now. So each test case, what does it do? It typically tries to what? It typically tries to establish the correct working of some functionality, whether a particular functionality is properly working or not. Take the example of library information system. What are the different functionalities? Issue book, return book, then check book, compute file. These are all examples of functionality in a library information system. And why you are designing the test cases? Each test case will typically try to establish the correct working of some functionality, whether issue book is correctly working or not, whether return book is correctly working or not, whether check book or check availability, search book is properly working or not. In search book, give this author name or the title name, see whether it is displaying all the available books or not. If books are available, how many issued, how many available right now, whether all those things are properly shown or not. In that way, we want to test the functionality of each. Okay, the functionality of the various functionalities in a software system. So each test case will typically try to establish whether some functionality is correctly working or not. This will establish the correct working of some functionality. What does it do? The test case executes some program elements. When we are designing a test case, it executes or it covers some program elements. What could be the program elements? The program elements could be statements, could be branches, could be paths. So what is the objective? We have to design some test cases so that each and every element will be covered at least once. If we are taking a statement coverage testing, we have to design test cases in such a way that each and every statement will be executed at least once. If we are designing a path-based testing, then we have to design the test case in such a way that each and every path will be executed at least once. For restricted types of faults, fault-based testing exists. If you want to detect a particular type of fault, we'll discuss examples. If we want to sort a particular type of fault, you can use fault-based testing. So for restricted types of faults, fault-based testing exists. So we'll take few minutes only, then we'll stop. So let's first define the test cases and test suits. So we have to test a software using a set of carefully designed test cases. I have already told you the set of all test cases is called the test suite. Now I have to say what is a test case. A test case is a triplet consisting of ISO, where I is the data to be input to the system. What is the input data? O is the expected output of the system. And S means the state of the system at which the data will be input, under which state you are giving the input. Take the example of banking information system. You are supplying what the input, such as you want to withdraw some money. So what system, what input you have to give? The account number, amount, etc. Now let's say where this S is there, S is system. Suppose you have opened an account before 2 years and you have not made any operation. Then obviously that your account will be dead state. So how many times you give your account number, amount, etc. It will not work because it is in dead state. So here we have to note down the condition. This is the dead state, we are giving this information or this input, that's why the system is not working. So in many cases we may not require this state, but only just by taking I and O we can test the software. But it's better you should also consider the state, under which state you are supplying the input and then you are observing the output. That state must be considered. So a test case is a template consisting of ISO, where I is the data to be input to the system, S is the state of the system at which the data will input, and O is the expected output of the system. Then what you have to do? You have to, what should be the actual output. Now you have to match the actual output versus the expected output. If the expected output is not matching with the actual output, then obviously some error is there. Then note down the conditions, under which conditions these errors are occurring. So note down these conditions. Then later on you locate, you debug and locate the errors, and finally you correct the errors. So this is the overall process of testing process. Perhaps now we are running out of time. We will stop here and next class we will continue from here. So is there any other class? If there is no other class, actually 15 slides are there, you could have finished. Let's see. MTech students, what are the next class?
No, sir.
BTech students, can I take 10-15 minutes more so that this lecture could have been finished? BTech students?
Sir, we have class.
We have class.
Okay, since BTech students. So
Sir,
BTech
advanced
students,
computer network class we have.
network class, huh?
Advanced computer network.
Okay, then we'll stop here. We'll discuss tomorrow. Acha, let me see. So tomorrow actually the class is at 8 o'clock. So can we take at 4:15? Everybody else free? BTech students? 4:15 is
4:15.
4:15 tomorrow. Are you free tomorrow 4:15? MTech students?
Yes, sir.
So BTech students are not telling, so they are not cooperating. Okay, I'll take at 8 o'clock.
Yes.
Huh?
No, we are free. Okay, we are free.
Not audible properly again, please.
Sir, he was saying
Yes.
that they are free. They are free. You can take it 8 a.m. Sorry, 4 p.m.
So is it okay? Should we take at 4:15? If all will say, I will take. Otherwise, I have to take at 8 o'clock. They are not saying, so we'll take at 8 o'clock. Okay, thank you very much. I'll take the attendance from the system. Okay.
Sir, can you take at 4:15 as you were suggesting?
But the BTech students are not saying anything else. That means they are not interested. 8 o'clock, it will be better they can sleep. By switching yes, by making on the switch with their computer or mobile. I don't have any problem. I'll take at 8 o'clock then.
Okay. We are free, sir.
Sir.
Yes.
Sir, 4:15 we have another class, sir, business research methodology. Friday 4:15, no, sir?
Tomorrow is Friday.
4:15 we have another class scheduled, sir.
Okay, fine. That's what I'm asking. I do not know. Our department timetable I know. Other department business research methodology is from MBA or so. That I do not know.
No, sir. Sir, intrusion detection systems 6303 Sujata Mohanty ma'am class is scheduled, sir. But actually, there is a problem. They're updating the timetable, sir. We'll get to know tomorrow.
Okay, so tomorrow 8 o'clock we will take.
Okay, sir.
Okay, thank you very much. Any other question? Any other doubt?
Sir, we talked about pesticide effect in the
Yes.
initial.
Okay, those who are having class, they may leave. Those who are having class, they may leave. Yes. Yes, Parananda, please.
Yeah. So is it something where you are introducing a new set of test cases to kind of validate the particular module or scenario?
See, there are two things. Either we may introduce some new test cases. If it is not still detecting all those things, we have to use a altogether new different testing technique. See,
Okay.
initial there are many testing techniques we will discuss. In black box testing, there are many techniques. In white box testing, also many techniques. So if one testing technique fails means it is detecting out of 180, only 80 it is detecting, another 20 left. So how many times the same testing technique will apply, you cannot detect the remaining 20. I have to change the strategy. For example, I have used only equivalence partitioning testing. Then I have to go for maybe boundary value analysis. Then I have to maybe the state table based testing. Many different testing techniques are there. Similarly, in the white box testing, suppose you have used statement coverage. It is detecting only 80, 20 are left. So what I can do, I can change this strategy and use this. Which one? Maybe condition coverage, because condition coverage is stronger than statement coverage. Then still something are left. Again, I have to search for a high powerful technique, maybe path coverage based testing. That is more powerful than what condition coverage. So like that, I have to change the testing technique. Are you getting?
Sir,
Yeah.
sir,
Yes, yes.
sir, how we will come to the conclusion that the testing technique we have used, still some of the faults are remaining. Let's say there are 100 faults. We know that 100 faults are there, but the previous technique removed 80 faults, detected 80 faults. Now, how we will come to the conclusion that 20 faults are still remaining, and now we have to use another technique?
See, let us take the example of this. You are writing a C program. While you are compiling, it is below showing that 5 errors are there. Maybe
Yes,
syntax
sir.
errors or whatever that. And what you are manually removing that? Okay, in first attempt you have removed 2. So it's saying only 3 are left. Second attempt another one is removed. Like that you can see. And in other cases, I will tell some other techniques where, see, those are all little bit what you can say approximated or estimated kind of things. You are estimating that there will be 100 things. And when you are next time testing, you are seeing that okay, these many errors are there, like say 80 errors are there, and from that you can know that the 20 errors still remaining. Actually, there is a technique I will discuss towards the end. In order to find the latent errors, what techniques we can use, these seeded errors, etc. At time will just maybe you just allow me 2-3 classes, then you will see how you will be able to find out the detect the remaining errors. We'll use some techniques. We'll say, let us proceed first. These are all basic things we are discussing. For the timing, you can assume that in a program, and obviously every approach has some advantages and disadvantages. These are what you are saying. These are the challenges. These are the threats. How to know? Very correct. Very good question. So for this particular or for this point of time, let us assume that there are suppose 100 number of errors. Then detection, you can easily find out when you are testing this thing. It will show that we are having so many tools. I will discuss actually the testing tools. It will show you the total number of errors detected is 20. Which kind of errors? Like that. It will give you the test report. It will give you many automated tools are there. And Tuesday we are having a lab class. So in that lab class, we will take up these different kinds of what tools those are available and see how they are giving you, showing you the number of errors total present, how many errors are detected, how many errors are left. So those things we can show you practically.
Yes, sir.
Okay, till now let us just assume this thing, but we will demonstrate those things in the lab class. I will take many tools out there. Actually, it requires your cooperation. The pathetic issue is that people are not cooperating. See, this time again only problem, they have reduced the number of classes. Previously, I take usually 4 classes for this. Now they have reduced to 3. And this semester also it is 65 number of working days. Previously it was 80 number of working days. So this time again horrible unless you will cooperate. So I will propose again next class the same practice you will take, because many of days I will have meetings, I will be absent like that. Tuesday class we have not taken, we may take on Saturday. So we have to again follow the same policy that we have adopted in software project management class. One class we have to take extra, then only may be possible. See, in software project management, I have worked very hard, but still 1-2 classes left. I could not finish, like Six Sigma, etc. I could not finish. But those things I already have uploaded in the website, Microsoft team. You can have a look. It requires your cooperation. Similarly, I will say that now this MTech, this laboratory software testing only for MTech students. But I will request these BTech students and PhD scholars, please join in that laboratory class. This will be giving a practical hand, what I am teaching in the class, how you can do it. Please attend this thing. At least I thought BTech students I don't have any control, but I will request the PhD students at least to join in the lab class, even if you have not registered for that. Anyway, this is the online class. So it will be not as much as effective as we do the lab classes physically, but still I will try. Let's see what is happening. So this Friday, this Tuesday, we will try to start the first lab class. Okay. So in that way, yes. Any other questions anybody wants to ask?
Sir, earlier you told about Ariane 5, sir, means why it failed, sir, failed to launch?
I have told now that example, Ariane 5, that example you are saying, na, Ariane 5?
Yes, sir.
Ariane
Ariane 5,
5, actually it was a rocket. For that rocket, these engineers, they have developed a software in USA. And why what was failed? I was saying that example, just see the slides again. That's a,
sir, you are saying like floating conversion, floating point to integer something.
yes. Just, is it visible? The slide is visible.
Yes, sir.
See, what has happened? You know this conversion from floating point to number to integer. Say when integer to floating point number, no problem. But while you are converting floating point to integer, then you know there is a problem. Are you aware of this conversion problem? How to convert floating points into integer, signed to unsigned, unsigned to signed? Do you know?
Yes, sir.
Then you know for this conversion, every type there is a range. What is the admissible range for floating point number -3 to 7, 6, 7 to something like that? For integer also, that I have forgotten that range. You have to see from the book.
Yes, sir.
That
Yes,
means,
sir. I remember, sir.
sorry?
I remember, sir, that range.
So you remember, if you will remember that range, what they have done, while that integer, that floating point number came and it undergone this conversion, then it has led to an exception, because this floating point number was larger than this prescribed value. This 32767, this what ultimate floating point number, it was larger than this. And as a result, it could not be properly converted to the signed integer. So some portions are truncated also. So this has led to disabling of that exception handler also could not work. This has led to the disabling of the exception handler. So that's why it has just, the software did not work. And if the software did not work, obviously you know what will happen. It has fallen down in the sea. See, a small aeroplane is running. If you see there's a small mistake there, can you just press the switch to held up in there in the air? No, immediately it will fall down. So similar control what software bug it was there in that Ariane 5 rocket, and that's why this has fallen down. You can see internet for the details. I have just because to show why testing is important, I have just taken a snapshot. The details you can find out in the internet also.
Sir, even
Okay, sir.
even in
Yes.
business applications, currently the business applications we are using, if the
Yes.
exceptions are not handled properly, so because you are giving different data sets for
Yes.
to use. So like suppose we're building an application for US client, let's say, or maybe UK client, their
Yes.
name nomenclature data they're using may be different than Indian data points. Sometimes
Yes.
it breaks because of the exception is not being handled properly with the data, different type of data we're using.
Yes,
That we
very
have
correct.
seen. Yes.
That if this cannot handle properly, then this conversion is not proper, then this thing will happen. So I am giving another simple example. In 2015, CCMT was conducted in NIT Rourkela. You know CCMT for that MTech admission. So the then director has made me the chairman of this local organizing committee for the CCMT. So I was handling these issues. And you know there are many refund cases. So like sport round, those who did not get seat, their money will be refunded. Those who have dropped and they do not want to participate after the first round, their money has to be refunded like that. So I have told my assistant register finance to prepare Excel sheet and give it to the blank bank to this refund for the refund purpose. So what he has done, you know, in Excel sheet, it is I think right justified while you will enter the values in a cell numbers. So what he has done, sorry, no, it is left justified. You know, different banks, they are having their account numbers are of different size. Like SBI is 11 numbers, PNB might be 16 digits, and so on. So what he has done while he has entered, he has not checked anything else, just entered all these person's bank account numbers. Then send this Excel sheet to the bank. Bank has transferred the money. Then in the night 10 o'clock is saying, sir, these numbers are we have entered. This money has been wrongly transferred. Why? Because the software has automatically added zeros at the end in order to make all them what same length. Because one is 11, one is 16, one is 18 digits. So the right sides have been filled with zeros. So this thing he could not have done, he could not have checked, he could not have tested. As a result, when the money it has been deducted, it is supposed to go to the some other bank or some other account having that what account number. So then he called me at night 10 o'clock. I could not slept because near about to 1 crore rupees have been transferred to maybe many people. And if 1 crore rupees has been just transferred to other accounts, then my Naukari will go. I will be suspended because I am responsible. That assistant register is not responsible. So immediately at night 11 o'clock, I have called to the bank clerk. What we will do? This has mistake has been occurred and the numbers have been wrongly what appended with zeros. So he told that sir, night 11 o'clock I cannot do anything else. Let's do tomorrow morning. So tomorrow morning, early morning, I rushed to the bank and we checked. Luckily, what has happened that those bank numbers actually were not given to any customer, and that's why the money has not been transferred. See, a minor mistake. The accountant has not checked whether it is left justified or right justified. Okay, if it could have been left side, zeros have been added, no problem. So due to lack of proper testing, say, how due to small mistakes, it has led to a serious problem where my job could have been gone. So these are the what you can say importance of testing. Before that, if I could have tested myself, this thing could not have occurred. Okay, so these are few of the examples I want to say regarding what is the importance of software testing. Okay, so Parvanand is saying good examples for this foreign clients when you are saying if there's a proper if they're not properly matching proper mismatch, then the everything will be in trouble.
Yes, sir.
These
Like
are very
suppose you are
safety critical. Yes.
you're
Yes,
giving
please.
a special character. Let's say sometimes the whole system breaks.
Yes. If a space or say special character or something you have
Correct, correct.
introduced, the whole thing will just crash.
Because that special character sometimes used in US clients or maybe something different names, nomenclature
Yes.
of the names. So that
Yes.
fails basically because yeah. So that's why we normally ask the customer to share the data set they are normally they're planning to use for their application. That helps us basically to avoid the defects.
Yes. So this is obviously there is some importance of software testing, and you will see the recent market now. Much of job opportunities are there in software testing. I do not know people are afraid of to work on software testing. Why? But if somebody will say that I know these tools, software testing tools, so companies are ready to accept you, to take you. Maybe some 7-8 tools because this time they will get less number of classes. So still I will try to practice some of the tools in the lab classes. Let's see how you are doing those things. But you please, PhD students, I request please you join in this join in these lab classes.
Sure,
Okay.
sir. We'll join. Yeah.
Okay then. So whatever is left, we will continue from the next class. Today, actually, from the morning, actually, this computer was showing some internet problem, and my TH they did not come up to 9 o'clock. So that's why this delay occurred. Otherwise, this thing could have been finished. So next class, I will finish all those things. Okay, then we can stop here. Okay, then. Thank you very much.